Hi, everyone, and welcome back to another Loki community call. We have a full house today. We've got 5 people. I am Nicole van der Hoeven, and as always, I've got my awesome coworker here.
My name is Jay Clifford. I've remembered my name once again this time. And I'm joined by the lovely folks of the Loki engineering team. So we've got Poyzan, Paul,
No.
and Julie. There we go. Have I got
Funny,
it in the
are
right
they all
order?
reversed?
Okay, the pointing thing is always a little dodgy.
I'm
But
called out first.
that one is Poison Tanelli, and over there is someone that we actually just roped in last minute. So we're lucky that he trusted us enough to come and let us grill him. Paul Rogers, thank you so much for coming.
Glad to be here.
And also we've got, as always, we've got Julie over there on that side. She is the Loki technical writer, so pretty much like everything that's on the Loki Docs site, she's responsible for. So thank you to Julie for letting us. I mean, I'm on there all the time, so thank you
Yeah.
for maintaining those.
Well,
But
and there's
today
a lot
we
of
are.
docs, so that's why I show up with these.
Yes, and she gets to ask all the
Restrained.
questions that she needs to update the docs. So we're like, yes, please come. But today we're going to be talking all about the Loki cache, the different types of caches that there are, and then also how to scale them. We've been talking a lot about how to scale Loki in general on Kubernetes. We just did one with Poyzan. And during that Loki community call, we were like, hey, what's this whole memcache thing? And where does that fit in? And she decided that there was so much to talk about on that it deserved it's a separate community call all on its own. So in this community call, we're going to be taking some questions, some that we kind of got in advance. But if you have any questions, particularly on memcache and scaling cache, and you can put them in the YouTube comments in the live chat. We will try to get to them. We will be prioritizing relevant questions. So if you have like more general Loki stuff, we'll get to them at the end, but we will go through the cache stuff first. And before we dive into stuff, we actually are going to be going to KubeCon. Jay and I are both speaking at KubeCon. That's next week. And if anybody is going to be there, come to both of our talks. Jay, you want to do a quick plug on your talk?
Basically, we'll be playing a video game on stage, which I'm quite excited for, teaching the concepts of observability. So metrics, logs, and traces, all through a text-based adventure. So I'm quite pleased to get paid to, play a game on stage.
Well, I wasn't going to say it, but yeah.
Nicole, isn't yours something about AI? What's yours
Yeah. So mine is called Asimov's zeroth law of robotics. It's observability for AI. The whole premise is that, as Isaac Asimov has these 3 rules for robotics about what they need to comply with so that they don't take over the world. But the law 0 that I'm proposing is that a robot must be observable. So how do we do that? Come to the talk to find out. And with that, let's get started. Paul, why don't you introduce yourself, actually, because Poyzan and Julie have introduced themselves before. Who are you? What do you do at Grafana? And how is it that you said yes to come on today?
Hi, everybody. My name is Paul. I've been at Grafana for 2 years. I think it might be this week, actually. It's 2 years. I've been on the Loki team for the entirety of my time. And I've been involved with a lot of the infrastructure over the last year, trying to make sure it's scaled appropriately and to work on making sure that everything's running as smoothly as it can. Honestly.
So I guess like fundamentally then, Paul, I feel like if we're going to sort of crack into the topic here, for people that don't know, what exactly is cache, and why does Loki need cache, and why do we use memcached, and what exactly is that?
Sure. So cache is a concept that is it's ubiquitous in computing in general. It's usually a software or hardware designed to speed up certain operations. In this case, we're dealing with software, and MEM is short for memory. So it's a way of quickly getting to information that you might need to get to very often. For the simplest case is if I run a query in Loki and I say, I want these set of logs, and then you run the exact same query. We don't want to have to go back out to object storage and fetch all the data and all that, because you just did it. And if we cache it, it's there, it's fresh, and it's quickly retrievable, generally at a low cost. So the technology that Loki is utilizing under the covers is a piece of software called Memcache. It's an open source project, and it's very scalable. It's a key value pairing sort of operation, and it's a wonderful piece of software, and we've utilized it for various parts of Loki so that we can do a query or whatever we need to do, get our data, and then put the information into the cache so that if we need it again in a short period of time, it's there for our usage.
And in terms of architecture, Memcache is its own container, its own pod. When we deploy Loki, it's not part of another service within Loki.
That is correct, and we often will have more than one pod so that we have some redundancy and whatnot. So we don't have to have this massive pod. We can have many of them, sized appropriately, and the data is shared between them essentially.
Nice. So like sort of moving on there you sort of touched on it a little bit. Sort of what are the telltale signs that you kind of need cache? What's the indicator? What do we look for to realize that we need this within our solution?
It's a great question, and it's something that we're constantly monitoring and whatnot. If you are working and you're looking at your data and you say, my goodness, we're going to object storage a lot, our bill is increasing, or boy, it's taking a really long time to get my query results. Those are all signs of, boy, maybe we need another bit of architecture in there. And in this case, it would be Memcache. It's a pluggable component in there that it should cut down on your costs for various object storage calls. I mean, we always have to go to the object storage the first time to get the data, but subsequent calls, if it's in the appropriate time frame, we shouldn't have to go fetch that data, so we save on costs there. And then if we don't have to go to whether your S3 bucket, for example, things should go faster as well, because it's basically in-house, which saves all that back and forth between us and the AWS servers.
So you're saying if you start to see that there's the performance slowdown, basically high latency, when you're trying to retrieve the results from the storage, that's when you should start to consider cache. But we have a question here from Jean-Christophe Doshi, who says, could you elaborate on the different types of cache we can use in Loki with Memcache, chunk cache, etc., especially the write cache?
Yeah, absolutely, and that was a topic that we are definitely planning on touching on, but we'll just jump onto it right now. The biggest cache that we have is the chunk cache, and it's the bulk of the data that you're fetching from object storage, as whatever you've written to Loki, that it's contained in under the covers, what we call chunks. And they might be relevant for one query and not another. For instance, we're going to write some Loki logs. The first line might be for user A, the second line might be for user B. The same chunk has both, but it may not be used in one query versus another. But it's still from a time frame and when it's being used. That would be an example of an item in the chunk cache, and we can leverage it for more than one query. We do have caches for are queries that do things like labels. What are the common labels that are used in a Loki instance? We don't want to have to go fetch that all the time. If we can cache some of that kind of stuff. Various metrics that we can create, those can be done with a hash. It's really it's pretty flexible. We have, we tried to separate it out, but the big one is the chunk cache.
So when you're talking about labels, is that what we refer to in the docs as the index writes and lookups?
I believe so. We are in the process of mapping all this out. Poyzan and I are new to extrapolating what's going on under the covers to what is presented in our Helm charts and our documentation. We're still putting all that together, but yes, that seems absolutely correct.
Okay. So you said chunk. Oh, sorry. Go ahead.
Jumping in there, like Paul said, we are mapping out because Loki is complex and things go out of date. And in the previous diagram, you would see Paul described chunks as the massive bits, which is where the data is. But this index needs to be removed because this refers to the bulk DB index, which actually use the cache. But since we moved to the STB store, TSDB store does not index its results. What it does is in the gateways, it when they start up and they download the existing files and they keep updating it as the compactor uploads new indexes. So their memory usage itself serves as a constant cache. The data is always there and constantly updated from the storage. So if you're not using VaultDB, you don't need what's in the values chart or in the JSONet, which is called index labels cache as type. And the results cache is, confusingly enough, and we apologize, this is the Loki style, organically growing. You will see in the JSONet as memcache frontend, but you will see in the Helm charts as memcache results cache. And Paul already mentioned, but the results cache is just storing results, and also the information that a result is not in the cache too. So go and compute it is retrieved as an information from the cache as well. Their sizes are in line with with the drawing here. Result cache don't store big chunks of data, so they're quite small. We will be updating, and I promise when Julie is here, we will be updating our docs and diagrams. Very soon, we have another doc sprint coming, and I take responsibility to do that.
So sorry, I think I got confused there. What was the thing that you said you don't need to use if you're using TSDB?
The index. Yeah. And the
Okay.
name in JSONet is memcache index queries. And then, I think it's the same in the Helm chart as well. Maybe it's even removed in the Helm chart. Maybe it's not even there now.
So to bubble us up back a bit, to sort of summarize and getting, so we can sort of track these out. So kind of what we're chatting about is we have free apart. If we exclude index cache, we're saying that's gone if you're not using VaultDB. We have results, we have chunks, and we also have do we still have sort of front end cache for basically metrics based queries like volumes?
Confusingly enough, results cache is the memcache front end. So they are the same thing. So we have two types of cache. One for the chunks, the data itself, one for the results.
Gotcha.
That's it. We just call it two different things. The results cache are called memcache front end or memcache results cache.
And then so if we bullet point then the results there. So in the results cache, we have things like log volume. We have what are other things that we get in results cache?
It supports three endpoints: the metrics queries, the label queries, and the volume queries. They don't necessarily store the result log lines because the log lines themselves are actually the chunks. So these are only for aggregated query results in that sense. Yeah.
Okay, so Andre had just asked. Andre is a champion too. Andre Ziviani. Does the results cache only log lines, or can it also cache metric results? So I think you just answered that, and it
Yeah, it's
does
the latter.
also.
Yeah.
Yeah. Okay. Okay. Wow. We just started. This is why we
Yeah,
needed
yeah.
it.
So
We
it's
just
like we
started, and it's already
needed to
confusing.
like break everyone in, and we just went straight into the deep end, like 2 meters deep. But we'll get there. I guess sort of like to sort of jump back up to the topic of why we need cache really quickly, and then we can sort of get back down to the architecture and tiering. Is we touched on it again, and Paul mentioned is what's kind of like the queries that benefit most from caching. Is it, you know, what we're looking at here? Is it like the same data over and over? Is it only log queries? Is it metrics queries? What benefits from specifically from Loki caching?
I'm going to say that in general, the answer is always it depends, but it depends how a user, a customer, whomever is using Loki. But the intent is data that you are accessing very often should be in the cache when it's all said and done. So it's designed to lower latency, lower object storage API costs. That also has the benefit of lowering bandwidth egress out to your object storage provider, any kind of throughput issues you might have there. So, but it's really anything you are using a lot or frequently should generally be in the cache.
So, and when we say using frequently, I assume we're talking about dashboards, things that you're monitoring in Grafana.
Yeah, and if you're querying data, I would say we tend to see certain query patterns that generally say it's recent data, but realistically, the cache should move to whatever is used the most.
Okay. And I guess like when you're talking about dashboards, a lot of these, I mean, we want them to be as in real time as much as possible. So, it would you be able to cache like everything? Basically, would you be able to do a time-based thing so that you cache everything that is older, because that's not going to be changing. That one you can just retrieve as is, but also still be fetching the new ones?
So cache it's a tricky item because ideally, yes, you want to be able to cache everything. You want to be able to have it right there for your instant usage. It's a trade-off. We could cache a year's worth of data, but that becomes very prohibitively expensive. So it's a trade-off on what are we using a lot versus, if I have to go fetch this piece of data from a month ago and I only do it once a week, maybe that sort of cost is acceptable. And there's a balancing act that has to be done. Each user knows best what works for them, or that's the goal here. Generally, it's you want the last week's worth of data, give or take, because that's recent stuff. That's most likely what you're querying in terms of Loki for logs. You're saying what just happened, what happened last week, and compare them. You have the ability to look up something from a month ago, but I would say that's often not as common.
Also, Nicole, let's not forget, just because the data is not in cache, that doesn't mean it's not served. Loki queries will always be served with the latest data. So what happens, let's kind of come down what happens when a query hits, right? The query hits, and then what we do first is, we're going to come down to this later, but we check if it's within the cache results. We have a handoff time, and then it will first look at the chunks cache. Do I have this data in there? And memcache naturally. So let's dive deep into how do we find an item in cache. So Paul already said memcache is a key value store. So our keys are chunk refs. So queries come and they have a list of chunk refs to find somewhere. The first place they look is the quickest they can retrieve, which is the chunk. Well, even more caveat, if it's less than 3 hours, if it's recent data, they know it's not even storage yet, probably. So they first ask the ingesters. And then we look at the cache. And then cache returns, hey, here are the items that I find for you. So you can retrieve the data, the value itself. And then it goes, here are the items are missed, which I don't have them. Then the same fetcher logic goes in and queries storage. So what we reduce is that storage percentage as much as possible. But the Loki as a software should always serve the correct data. That's what it's designed for. So it doesn't really matter. What we try to save here is like more or the cream on top, so to speak, if that helps.
So I guess sort of to sort of finish off as well, the architecture of cache is when we focus a lot on like the chunk cache, and then there's this idea of like I see in the Loki Helm, there's this idea of tiering. So can the chunk cache be tiered? Can there be tier 1 and tier 2? And what's the role of tiering in cache?
I'm not sure I follow the terminology in that
There's
sense of tiering.
So essentially, I think it was a user had basically created, let me see if I can find it. It's like between like L1 and L2 cache.
Okay. Then let's dive deep into how we further complicate our chunk cache to make the best out of it.
The architecture, yeah.
Okay, L1 and L2 is what you mean by tiering. Sorry, because the terminology didn't one-on-one match.
Sorry.
No,
that's why we're confused too. Like what? So what is tiering in this context? Why does it have to be tiered at all?
So I see some questions in the chat about how to tune it. So let's dive into how we run our cache at Grafana for Loki and touch upon tiering. But then let's come back on how we monitor it. So what happened is as Grafana grows, as you know, at Grafana, Loki handles in the order of petabytes of data a month. And it is now, about 2 years ago, it became prohibitively expensive to hold as much as possible data in memory, just in memory. And then there was also one more kind of yellow flag that was presenting itself. We were pushing the bandwidth limit of cloud providers because we were asking for too much data at a time from storage layers, because we didn't have it in the network, so we had to always constantly go to storage. So our lovely colleague, Danny Copping, as we mentioned them in the last call, came up with this idea of it's an extension. It's again open source supported extension on Memcache called Memcache Xstore. So Memcache is an in-memory design, but Memcache Xstore attaches SSD disks to whatever container that runs the Memcache. And then by design, the key mapping is still in memory, and Memcache works as it does. So it gets all the data in memory, but then flushes to the disk. So we exponentially increase the capacity of our cache. So what we use is we started rolling out that in GCP. And I see some questions particularly about node types. It depends, availability depends on the region, but both AWS and GCP in most regions provide standard nodes and that support SSD attachments. So we generally choose those nodes. What we try to optimize is a fairly generous CPU, which is generally around 8 cores, but a little bit higher on the memory, at least 16 or higher. And then we started using this, and we call it L1 cache. Now we have this huge storage in the order of terabytes of data that we can hold with a number of nodes. Relatively few, around 30 to 50, let's say. And then we further came up, Ed Welch came up with a further optimization on top. So what he realized, how does cache work, right? So we briefly explained, a query hits, we look at the chunks cache, and then we say, here are the hits you have, return data from cache, and here's the list of misses you have. So what we do is now, we need to update our cache. So we serve the query, getting those chunks from storage, And then when we get those chunks from storage, we also say, hey, write back to the cache, because when they're asked again, now you have this enhanced data and like larger period of time. And what happens? So this is coming into like a failure scenario. And if I'm talking too much, do cut me off, please. But what happens when you try to write? Look, so you provision, let's say, about 5 days worth of data, and you have this user that constantly queries 6 days of data, slightly longer than your periods. So what does this do to your caches? You get most of, like 90% of the data from your cache, but that 10% constantly tells your cache to renew itself and tries to rewrite, which comes back as like high compute, unnecessary writes, and a performance bottleneck for the cache itself. So we introduce another memory in-memory cache, a small one called L2, which is a spillover logic. So we have the majority of data on disk, backed by XSTOR, and then we determine a handoff periods, about like a couple more days more. And then we hold as much as data in memory for that. And then when the query hits, we look at the handoff time. So it says, we first check if you're within the handoff time of L1, check L1. If not, check L2. And the spillover, if there's this like extra day that constantly needs to be written, then we protect L1 from constant writebacks, because it serves all data that is asked, and then anything else comes from L2 or storage. Does that help? It's fairly complicated to follow, but that is the tiering that we introduced.
No, that's really good. And we also definitely want to get into scaling questions in a bit as well. But maybe we could step back a little bit and then talk a bit more about the different types of cache and what each of them stores, just so we all are on the same page about the terminology.
Yeah, let me take it from the top. So what, like we already talked about the two, right? The memcache front end, or in other words, result cache. We don't do much tuning on it. It does its job. It's fairly small. We run a few replicas of it, and then for repeated like volume and metric and label queries, it stores a result, and that's it. But for chunks, now we talked about two different types. Loki by default comes with memcache chunks cache. You can enable it, and it will provision, when you increase replicas, it will provision simple in-memory memcache instances. There is another type that we can do, and we run internally. That is the same memcache backed by XSTOR that is supports the SSD disks. So we still talk about a single type of cache, but two different modes of running it. And then to enhance the second mode of XSTOR back to running version, we also introduce a tiering L2. So I want to take a moment here and say, when is this relevant? I think this is relevant if you are dealing with at least 0.5 petabytes of data a month. We still have like a number of clusters that we don't need XSTOR. I mean, it's even complicated to verbally explain, right? Like we talk about this version and then an add-on and an add-on on top. So it's actually quite hard to maintain. As the natural organic query patterns change, it's hard to maintain that handoff time. We're trying to automate it like as much as possible, but these are all added complications in your complexity in your system. So I think when you're running production clusters, when the storage costs become noticeably prohibitive, then a solution like XSTOR is relevant. Cache is always helpful. It should be started. This is our message always, right? Come back to fundamentals and the simplest. Start with a few instances. There's a question about that basically says,
well, let's go through let's pull back a little bit and talk about the different types of cache first before we dig deeper into scaling, just so we get some of these other questions. For example, we have a question on chunks cache as well from Andre Ziviani. Let me just find that. Can you talk a bit about dedupe? I believe the chunks cache is used for that. What is a good expected ratio? Paul, do you have any thoughts on that?
Oh, that's an interesting one. That's an interesting way of looking at it. Andre, can you confirm if we understand it correctly? Because so Loki creates redundancy because we have zone awareness, and then we create duplication on storage layers. And if there's duplication on storage layers, and if queries pull that data, they have to dedupe the queries. But if we get it from cache, we get one copy of it. Is that correct? Maybe we wait for the answer, because Paul, is that your understanding as well? Because I wouldn't necessarily link deduplication with cache immediately. Okay.
It's a good question. I mean, I'll be honest. I mean, I've been looking at the memcache stuff for a couple of weeks now. I think, but deduplication on the write path. This would not be involved. This is really more on the query side of things. We don't write things into the cache until they are actually queried, as it's currently architected. So the write path just puts things in as is. There is some amount of duplication that is done. Some chunks are duplicated within the storage. We do our best to minimize that, and we have efforts ongoing to lessen that. But when we go and do the query, that's when things are actually written into the cache.
And for that metric, Andre, like duplication happens when ingester zones go out of sync. So if one of them flushes open, if they scale down or up, so if they're running happily, flush rates should be in sync, and that's when we do the best deduplication. But there's no particular intervention that we do in the existing write paths. And what I'm thinking is that the chunk refs probably are different. I'm not sure about that. So on two different ingesters, if chunks are different, and if there are two copies of the same chunk on storage, we will have two copies of them in the cache too. I need to really look at the code path, how that works. Yeah, but it wouldn't help with the existing duplication. All you can do is like keeping ingesters happy and in sync as much as possible.
So I kind of want to I know we've sort of like we've talked a bit about the chunk cache, talked about the result cache, and we've sort of dabbled in the tiering, or sorry, I refer to it as the tiering, but the spillover cache. What I think it'd be really good to get to is when we start sort of dabbling in the scaling side of memcache now, is I think Poyzan, you touched on it when you were talking about the different sort of spillovers. You said roundabout in Grafana Cloud for Loki, we keep a 7-day worth of cache, about the 7 days worth. And I wondered if you could talk us through the decisions that you arrived to get to that. And I think this will sort of help our community work out how to size their cache, what sort of the best practices to look at when you kind of visit how big your memcache should need to be for your own Loki solution.
The way we come to 7-day is basically we look at the query behaviors of our users, and we look at two things. If the ingestion pattern, so if the amount of chunks that is on storage for that cell has changed for that cluster, if it's increasing because 1 day worth of data now means more data, we have to monitor that. And then what is the average query period that these majority of the customers do? And what we notice is, and this is a very rough heuristic that we try to now look back in and further verify, is about 7 50 to 70% of, let me rephrase it. Generally, keeping 7 days of data is good, because most customers, a percentage of, like a high percentage of it, depending on the cell, will hit that much data. But there are such cells, this volume is like insanely expensive for us. There are such clusters for us that are so big, 7 days of data is like quite a generous amount of data. So then we try to like tune it a little bit. It's like, then we ask another question. So how much IOPS, how many access to storage layers, S3 layer, that we save by provisioning cache? And then we come up with a heuristic. It's like, if we kind of try to save 70% of the IOPS that we do to storage, if we have no cache, then the cost of the cache offsets itself. So what we save from not accessing storage kind of pays for our cost of cache. And then that's what we try to optimize. But that's very hard to keep on top of. So we try to now simplify that heuristic by creating a recording rule on what exactly the amount that we fetch from cache, and then try to optimize around it. And that's the work that Paul and I have been like diving deep lately. Does that help?
Yeah, so essentially what we're saying here is for people trying to work out how to size their cache, is they should look at how much data that they're bringing in, what's their regular query workload. So say if they're looking at constantly 7 days back or 6 days back, and they should be accommodating their Loki cache size to meet that requirement. And
exactly,
then,
and we can actually go through a numbered example if that helps. So
that'd be cool.
Yeah, let's say your whole we have about 1 terabyte of data a month in our Loki cluster, right? That makes roughly 30 gigabytes of data a day. And then now we the storage and I'm assuming this is a setup that is connected to an object store, like a cloud provider. This is not on file or anything. We are a little bit bigger for that. And then we know the cost of storage for us, right? But the cloud provider kind of says that, and we can calculate. And then we also know the cost of spinning up a pod with a certain CPU and RAM. And then now we are dealing about 30 gigabytes of data. And we often query, we have a dashboard, we always look for that day. So if we provision 5 replicas of in-memory memcache that has about 10 gigs of RAM, that should more or less, it's 50 gigabytes of data. We should be able to cover more than a day and a half, right? And that's generally how I would start. So I would look at how much data I have, and then how much data I want to retrieve back frequently. And that's the starting point. And it's always possible to further complicate it. But then let's provision it. What should we monitor for the health of our cache, right? We should see a reduction in the storage access. We should monitor how much we go to storage, and there should be significant drop if we tuned it correctly. We should look at the read path latencies and make sure that reading or writing to cache does not introduce added latency to our pipeline. And then further monitoring the memcache metrics helps. Like, can we write enough efficiently? Can we monitor the bandwidth of the nodes? Are we abusing something in the network that slows us down? Then we can further dive deep into diagnosing that. And this suggestion assumes that there is no further tuning happened on the Loki. So you use the Loki defaults about 1.5 megabyte size chunks, that where memcache comes with 2 megabytes of what's called max item size, which can be imagined as like a single box that memcache uses to put data values in. So those are by default in sync. But let's say if you played around with your Loki chunk size, and if you increase that, and then you didn't change anything on your memcache configuration, you may notice a discrepancy where memcache doesn't work. And then that comes down to going back to bases and like following how you configured your Loki. But by default, the three signs is like how much data I have, how much data I need back, and what does my storage access look like.
And I think one other easily overlooked item is the fact that once you've set up the cache and you think you've tuned it properly, you need to wait a little bit before you evaluate it, because the cache is empty to start and it has to fill up and do its thing. And then after the cache is running at more or less what we'll call a steady state, then you can start looking at how well it's performing. Poyzan and I have run into this as we've been tuning the cache. We have to wait, 4, 5, 6, 7 days before we can actually look at the statistics from it.
Oh,
Because
that's
we're trying to put terabytes of data in this. It's like
that's super interesting. So you have to leave it a constantly running production time, get those metrics in, and then basically revisit that evaluation and see if what your hypothesis on like the scale is right.
Mhm.
It's frustrating as a developer. It's like I have to wait to get my results, and that's not why I did computer science, but it's the way it works.
Well, this ties into, I mean, we're already sort of answering it, but I thought maybe we could tackle this. A question from Matt Vetas, who asked earlier, what are the key metrics to look at to know if the cache is correctly tuned? And it looks like this is the approach that you're talking about, where it's not something that you can calculate exactly beforehand. You can start with like a rule of thumb, but then there is an element of looking at the metrics afterwards and then kind of like course correcting on the fly. You mentioned a few things here. You said IOPS, the bandwidth usage, the computation cost, latencies. Is there anything else that you would add to that for the key metrics?
So the
thing sorry, go ahead.
The Memcache software itself is a fantastic piece of software, and it has statistics that you can query directly. So you can telnet into a Memcache pod and run a command called stats, and it prints out all kinds of information. And it talks about hit rate, it talks about eviction, how fast something is removed from the cache. It talks about how often the cache is compacted to make sure it's appropriately shaped and lined up correctly internally. So you can use that in conjunction with the outside metrics, like looking at your object storage and your query latency and things like that. So there's all kinds of metrics that you can look at to tune a cache correctly.
And I would add, like, Memcache is designed to maximize all the resources that it has. So a correctly tuned Memcache should have about like over 90% fill rate, and then it should have over 90% hit rate. And when you have, I mean, that's at least what we aim. And when you have like abnormal query pattern that forces it to evict too much and write back too much, it's normal to have temporary drops in that. But overall, like close to 90% of utilization is what we aim. That's why Memcache has, so when you provision Memcache in a pod, you provision the pod usually, like you set your CPU request and you set your memory request, but there's an internal memcached memory limit that you should aim to set around like 90% utilization, because if it's like too much or too low, Memcache would limit its own memory utilization to that. So a correctly tuned Memcache should never because the software's memory utilization should be around 90% of the pod's memory request, so that it's like nicely utilizes the max possible, if that helps. And these can be found in Memcache open source docs as well, how to make best out of it. That's why we kind of like to use it. It's such a proven software that is like easy to onboard. I love it, honestly. Yeah.
Okay, we also got a question about Xstore in particular from Lucas Januszaitis, I think Lithuanian. Labas. and Achu for your question. Hello, really enjoy this community calls. Kudos, thank you. When using memcached Xstore, oh my god, these things are hard to pronounce. What is the recommendation when to scale chunk cache pods vertically and horizontally, and when to scale the PV size?
So that's a good call. They don't actually have persistent volumes attached. They literally have disks attached. So that's one thing to clarify. That's why you need to choose and provision a particular instance type based on your chosen cloud provider that supports that. So that's one thing. I think it's a great question. I love it. Like Paul said, it depends. We prefer to run our cache nodes on dedicated node pools. So we have absolute control over our instances, and which I assume will be the case for like most of the listeners here. And further than that, we aim to maximize the utilization of those nodes. So if what we did so far, we can tell from experiences, like we experimented a lot with different types of nodes. We looked at Danny did most of this work. He looked at the bandwidth that they come with, number of disk attached and the capacity, and their RAM and memory. And we were able to run with them for about 2 years. And now we are like, coming to a certain size. This is the first time we wanted to reevaluate that. So it's not necessarily quite often, but I would just recommend try to maximize the utilization of the node type that you choose. And like said before, try to choose a node type that is relatively modest in compute, like 4 to 8 cores, but then more generous, relatively a bit more generous, like 16 gigs of memory or more RAM, and number of attached disks that you want to choose. Hope that helps. And in relation to the previous question, one thing I want to add is you don't want to regularly try to right size your cache vertically, but what you want to regularly monitor is the change in your write volume and query volume. If you start to all of a sudden query more data frequently, you may want to increase the capacity. Or from the other perspective, if you start all of a sudden logging more data, then the set capacity of your cache now holds less amount of query period, right? If you double your ingestion, and if you used to cache 4 days of data, now the cache capacity will only be able to hold 2 days worth of data, where you regularly still query 4 days. So you wanna monitor the use of Loki and then adjust the cache horizontally. But I will argue if chosen correctly, you shouldn't need that to change them vertically. Yeah.
So there's a really good question in here. I know it's sort of like changing the subject a little bit, but I feel like it's been good because we talk about a lot about how we want to sort of size based upon our regular intervals of data. And I believe I'm going to butcher this name. I'm so sorry. Labez. So sorry, Labez or Labez. They're basically asking if, and this is like an ED query, we're going to classify it as, where you do like a 30-day pullback of data. What's the best way of preventing sort of looking into cache, or I guess sort of writing back into cache, where you might sort of hit like a failure scenario because you want to do a much more intensive query in this sort of situation?
So I wanna call out, shout out to a community member here. Their GitHub handle is mvetas or MEITAS. Sorry for that. But basically, this was a use case that they needed, and they reached out about 3 months ago. So yeah, they had this rare use case that they need to pull the longest retention data, which was like erasing all their cache, evicting everything in there. So they introduced a flag that is called, and Jay shared the PR, skip query write back cache older than some time. And then this basically says, like, if it's, I believe it's, yeah, if I remember the PR correctly, if it's set to 0, so it will just skip the cache altogether. Which is a fantastic way of, if you have this use case, it's a great way of doing it. And thanks for that contribution.
I'm so glad that naturally got plugged by a question from the community. It was just like self-served from the community.
Stages, yes.
I also have to have a huge kudos to Matt in the community, as well as putting in that PR. He is such a saint when it comes to answering questions and talking about people's sizing. So massive thank you to him in the community. He's always in Slack, sort of answering people's questions.
Yeah, I think he's also here. He's the one that's been asking some questions.
Is he?
Make
Yeah,
sure-
sure he is.
Yeah,
Oh my
he's the one
days.
that asked about the tuning, the key metrics for knowing if the cache is correctly tuned and stuff. We'll
Sorry,
make sure
Matt.
to answer some of his stuff too.
Sorry, Matt. I did not tie you together.
Can I? Oh, now I see. It's Vetas. I see a question from Matt that I got excited about. Is it normal to see a lot of timeouts when queries are communicating with the memcache? This was a case that we ran into a couple of months ago. I mean, we think it's been happening, but it kind of intensified and get our attention. As when the cache timeout is so high, we notice that the query is timeout waiting because we are graciously giving so much time to cache. The queryers are just waiting and go like, "I'm sorry, I didn't get my data," and then they go like, "Sorry, timeout 500s." So what we did is like we reviewed the cache timeouts we have and we drastically reduced it because it's under normal circumstances when cache is functioning fine. It's not a compute heavy process. It should just immediately find it and tell if it exists or not. It's a hash map lookup. So we reduced the chunk cache timeout to 200 milliseconds. And then L1 even, we consider, I didn't merge that PR. It was late on a Friday. We consider the same thing for L2. So because it's in memory, even drastically reducing. So please try that out. And if it doesn't work out, or if there's something else, we can look into it. But that might be one of the reasons. I believe the defaults might be too high.
Oh, we've lost you, Nicole.
Oh, sorry. I hardware muted myself. Maybe we can also talk about monitoring memcache in general and seeing if it's being utilized by Loki. In particular, there's a question by Jean-Christophe here, and they ask how do you check how the different caches are actually working? For some cache, like index queries and index writes, has 0 for the metric memcached current items.
Yeah,
Is that
I think
because this is the one where they're using the TSDB?
I believe so. Yeah, because the defaults are still there. It exists, but it's not in use. If you're on TSDB, there's nothing that hits that cache. That must be.
We'll have to check if that's in the Loki mixins under that Loki operator still, or just get rid. That'd be a thing to check after this.
I think Loki mixins, if I remember correctly, like they pull in all types of cache because the container all is memcache. So whatever you have, all enabled cache will be listed. Okay, great to verify that with Jean-Christophe. So whatever cache you have enabled, it will list all types. we don't have a, coming back to monitoring, yeah, no use to set it option. Yeah, you can just get rid of it. What was I saying?
Monitoring
Monitoring.
memcache.
Oh, thank
Yeah.
you.
Like for
Back to
other
monitoring. We
types
don't-
of cache.
Thank you. I'm sorry I forgot that. We were working with Jay. We noticed this. We don't have a dedicated cache dashboard that is in the Loki Mixins. If you guys feel we can, like, we can try to invest time in that. But what we have is in the Loki operational, there is a separate row for that shows the latencies. That is, I think, hits and misses from storage, and then the latencies. That can be enhanced with some more like memcache provided metrics, or we can also come up with a separate one. We have some internal dashboards that are dedicated to XStore, but we want to underline again that XStore is a very specific use case that is a significant complexity introduced to the system. So that's not something we necessarily want to push the community towards, that like you should do this. Oh yeah, that's cool. Like out of the box memcache metrics should be good. This is the rows that I were talking about in operational. Thanks, Jay.
Yeah, I mean that'd be great to know if people do want that. Just let us I mean, if you want to comment in the community, just let us know, because we can release the initial new version of this and then we can add to it as we go. And did someone just say, sorry, did I just miss that someone said there is actually already out of the box measurements for memcache that would use any dashboards that are available from memcache themselves?
Yeah, so Paul was saying earlier that memcache comes with some statistics. You can just do stat on it, and then it gives you a bunch of stuff. And then Jean-Christophe was saying that there's already a Grafana dashboard for that stuff, so
Sweet.
you can use that. Not from us, but apparently someone made it. It's great.
We can pull that one in. Wicked. Okay, cool.
Yeah.
Sweet.
I wanted to know, you mentioned, I think Poyzan, you mentioned that you and Paul have been working on the cache recently, and specifically about the recording rules. Can you talk a little bit about those? Because I was kind of thinking that they're separate in my head. It's like, when do you use a cache versus when do you use a recording rule? So I mean, maybe you could give your opinions for that, and then also talk a little bit about the work that you've been doing and how they're related.
I can do the clarification, and then Paul, maybe you want to dive deep into what we are doing. So, to me, cache and recording rules are slightly, maybe not apples and oranges, but maybe oranges and satsumas or something. It's basically because a recording rule is when you do the same aggregated analysis on a group of logs repeatedly, that's when you need the recording rule. And the context that I mentioned it in was is now we want to get how much data we get from chunks. How much chunks we get from cache, and we have a log line for this in metrics.go that is logged by the queryers. So because we want to access that data particularly and regularly, we are introducing a recording rule for that. So that's that repetition. Cache is a way more generic concept, that when you need any data regularly, that you can put it in a temporary storage and then constantly accessing it. So yeah, make use of recording rules separately. And then when you particularly want to like do the same analysis, or like alerting or something over the periodically over the log lines that come in, but treat cache separately, because cache serves all your queries, whereas recording rule is a specific query that you focus on. Hope that helps. And then Paul, you want to share our work?
Yeah, what Poyzan and I are doing is we had another colleague that started work for trying to dynamically size memcache. because this tuning process, as we've certainly alluded to, is complicated. There are a lot of different factors. And so some of what we've done has been introducing recording rules so that we have data that is easily obtainable, that isn't costly. And we want to try to automatically scale our caches up and down based on a variety of items, such as how much data is being ingested, how much data is being queried, what's our hit ratio on our caches. And once we see things out of a certain threshold, then say we might need to add more cache, or we might need to lose some cache so that it's appropriately sized. And it's going to be a heuristic, but it's a lot better than doing it by hand every few months.
That sounds cool. We have a question from DJI 101. Love those drones. So what are some recommendations for chunk pod sizing when ingesting 2 terabytes a day? Also, is persistent volume claim storage recommended?
Like I said, like no, our memcache config does not use PVCs, and 2 terabytes a day. It's tricky. I don't know how much you access, how many people access it. Do you open it once a day and run one query, or like is there during the workday, is there a dashboard open constantly pulls that data for like a week? That's different. So if it's, again, analyze your access pattern, and there's data for that. There's a metric called queried bytes on I think Loki tenant query bytes, and then you can see how many tenants, and then you can further do like an analysis on metrics.go line. What is the period they hit? And if you don't want to dive deep in any of this, you can start by just provisioning some in memory. But because we're in the order of terabytes, and if you want to kind of cache more than a couple of data, the Xstore config is available. You can also start with that. We try not to do instance recommendations. Everybody like uses different providers, and then providers' recommendations do change depending on the region. So you can also dive deep. We can share at the end, maybe in the comments, that Danny's blog post on Memcache. That's an excellent resource. He also has contributions to Memcache Xstore open source documentation that specifically tells how Loki Memcache Xstore is configured. We can share those 2 resources, and they can like serve as fundamental. That is the blog post, and I'll find the OSS docs, Jay, Nicole. And I'm sorry, it's a very much a it depends thing, but like don't be afraid to provision some, see how you fare, and then change it. And then start with in-memory. Generously start with in-memory because it's so easy. The configuration is already there. Provision like 60 pods. I don't know. But in general, like with, I don't know, 20 gigs of RAM, right? Then you will get some amount, and then see how much you save, how much it costs us, and cost you, sorry, and then take it from there. Don't try to jump into one or other solution without trying the simplest and most available first.
So I guess my takeaway from this whole conversation on cache is like there's not a one size that fits all. It is an organic process that you should like measure and continuously reevaluate, like we do like every day now for our own customers. So I think that's the cool takeaway here is the depends makes sense because you need to have a go and work it out yourself based upon what Loki's telling you in terms of his health statistics back. So yeah, I guess like I think that adds to my excitement to add Memcache to the Loki mix-ins. And I think Matt also alluded to if we can like get the rules once you and Paul are done, if we can add those to the rule list in like the Loki mix-ins as well, so they've got some idea. If we can, that would be pretty sweet. Yes, I'm seeing nod. We're saying nods is it's going to happen. Community, they're Paul and Poyzan are agreeing.
Mine
Okay.
was more of an agreement, but yes, Loki is wonderful in the fact that you can run it in a very simple way or a very complicated way. You can run it just as a single binary, or you can run it as hundreds or thousands of pods, and no one solution is the correct solution necessarily. The answer is always it depends. But we need to definitely provide more tools for the community, and some of these mix-ins and recording rules will definitely help with that.
Oh, thank you, Paul.
Awesome. Thank you all so much for coming on. We're already a bit over time. We could have kept going on cache stuff. If there are some questions that we didn't get to, or if you have any, if anybody who's watching this after the fact has any questions, put them in the community forum, actually, because that way other people can see it too, and they don't have to go to YouTube to find it, and we will get those answered for you. Any last words from Poyzan or Paul before we close?
Thank you so much for having us, and thanks for the great questions on the chat. It felt very naturally organic.
Yeah, thanks for
awesome.
Great questions. Glad to be here. Glad we can help, and looking forward to helping more.
Okay.
Cool. Well, thank you, everybody. Have a good rest of your week.
Before we lock up, somebody asked for a question in the next topic, and I know you guys already have a couple lined up.
Oh, yes. Oh, Bloom filter. Oops, wrong one. Bloom filters. Actually, we already did one on Bloom filters. If you go back through the previous Loki community calls, we talked quite a bit about Bloom filters a couple months ago or so.
Yeah.
So have a look at that, and I'm sure we will tackle it more in the future again. All right. Well, thank you, everyone. Have a good rest of your week. See you next month.